Can I ask a very quick question while you're getting sorted, Vic? Do you monitor access times, given the huge numbers of file creates?
We have monitors, but I'm not sure exactly.
Record access times, because that's a whole bunch of load. It's access time, not creation time.
Access time. Yes, we use access time for the rules.
That's what I mean. So you have to be updating them every time you open a file for read.
Yes,
so that adds a whole bunch of extra.
Yeah, but that's the things that are used from a lot of scientists. They use that for their own internal workflow, so we can't really get rid of it. And also we use for the rules as well.
Okay, so thank you.
Okay, so access time is required, really. So has anybody got any questions from either of the talks by Michelle or Gwen? Hands up, don't be shy. Andreas.
Pressure.
What is CDS? What is CDS?
It's Cray Data Services. So it's the system that Cray developed to move data automatically following a set of rules from one tier to the other, or just moving, if you want a file automatically to get stripes, you can do that as well.
Anybody else? Any other questions? I've got one. Oh, no. Yes, sir.
So going back to what you were mentioning about making sure your system's resilient and you move stuff off when you're reaching capacity.
Yeah.
How do you stop users, because I've thought about this, how do you stop users just saying, I'm just going to touch all my files?
You don't. You go there with a very big stick. It happens in the past that we have some user that were doing very bad things to the metadata server. Yeah. And once you find out which user are, you quietly bring them in a dark room and tell them not to do it again.
Okay. Yes, Robert.
Hello. It's a sort of a question. Gwen had the drive to make a Lustre as fast as possible.
Yes.
And I'm kind of looking over to Alistair, who up in Durham, I think, set out to achieve the same goal-ish. So I did my dropping. So I think you chose to keep the metadata resilient, but then just had the flash drives non-resilient straight to the machines. Was that correct?
That's right.
Oops.
Can we get the microphone turned on?
I think we raid the metadata, but it's only on a single server.
Okay.
So if the server dies, you lose the metadata until
you lose the metadata.
I will admit, I cribbed with Alistair a bit, so I've also learned from that dragon.
But it has been. I mean, it's been in production for what, 4 years, 4 years.
I seem to remember you saying the actual failure rate of devices was remarkably low.
That's right. So it's
that's what I've taken home. And one other thing, which actually may end up with Andreas, because I'm thinking backwards, with AI, the biggest driver I think of the storage from AI is actually to checkpoint the stuff before the GPU dies, because they're not very well made. Can you arrange it so that you have the NVMe, the OSTs inside the same machines? Can the GPU machines themselves be OSSs or OSTs, and then you're not hitting the network for the checkpointing?
Well, for certain you can mount as a client inside as a server at the same time. That definitely works.
You could, if you tell it to write to that particular OST, it would then write there directly.
My inclination was to go for something like PCC, persistent client cache, and then migrate the objects to the local storage. But the downside of that is there's some interesting problems related to file level redundancy for PCC, which has been a bit of a sticking point on that one.
Okay.
Because I'd like to have a remote copy as well as the nearby one. Thank you. That would be very nice. But yes, I haven't considered operating them as OSTs on the boxes themselves. That's an interesting solution.
I came across
but if you use 2 boxes, then they'd have to talk to each other about storage, wouldn't you? You build a little cluster. If you use 2 GPU boxes worth of GPU, and you use the OSTs on both GPU boxes, then we assume that if they write a big file, they'll be writing across the OSTs on both GPU boxes.
If you pull them that way.
If you pull them that way, that's not how I would. What I've heard presentations from people running AI farms, is that the GPUs themselves are actually quite unreliable when they're really, really hot.
Yeah.
And so, but I could imagine someday then your control to size the pool of NVMe that's local to each GPU to be big enough to hold the snapshot, because that's not the thing that's likely to fail while you're running this big job off across 100 GPU nodes.
Yeah,
You want
but
to
they
get those
would still need
snapshots
to-
out in 10 minutes and carry
But
on.
they would still need to talk to each other, though, wouldn't they?
No,
No,
you
no,
could.
you'd
So
have to admit-
let's take a hypothetical circumstance where you are running a job and you've created a pool on that node. You then write your objects to that node only,
Yeah.
and only the metadata is communicating somewhere else.
So that's,
But if you're running a multi-GPU job that
Yes,
runs across...
under those circumstances, yes, you would
Yeah.
need to spread over
Okay.
multiple different servers, but that's acceptable because each guy can talk to each other.
Yeah.
Yeah. The advantage of doing that is if the servers don't blow their heads off, which will occasionally happen, then you can actually then get access to the objects and move them. So if you have a failure on this chunk, if the GPU dies, and then you have objects here, but you need to restart the job over there, it would then potentially be possible to migrate to the snapshot and then restart it directly over there.
this is getting a
Which is
better idea all
very
the time.
interesting idea, actually.
Yeah.
I
Andreas.
like that.
That depends whether the GPU failure causes the whole node to die or not.
Exactly. Yeah.
Because otherwise, you're writing your snapshot on the same node that is dying because the GPU has caused some problem and
Yes.
you can't access the snapshot anymore.
That's the exact same problem I had with PCC, because if you move the objects via PCC to the local node and then that node kills itself, then you lose the object. So it's like, okay.
I think you'd take advice from the people who are seeing these failures happening fairly frequently, but the implication I gave was the GPU burnt out, not the server.
But does that cause the server to crash when the GPU dies, or does the server stay up and the GPU is dead and non-functional, but the storage and network is still accessible and the CPUs?
Well, you're checkpointing periodically, so the fact that you have to go back to the previous checkpoint and pick up and carry on.
If the checkpoint is in the same domain as the failure,
Yeah.
then your checkpoint is inaccessible as well, right? It just depends on
Yeah, no. Whether
GPU
with the
failure takes the
even
whole
if the
node.
GPU takes the node down,
Yeah.
if you can take the GPU out and get the node back up again, I see that
But
point.
whilst the node is down, you would not be able to access the checkpoint.
Yeah,
So you couldn't
absolutely.
restart it until that hardware had been replaced, which is a bit disruptive. So there is definitely a downside to it.
Yeah.
Just wondering because if you have a lot of nodes, you have not only an automatic way to check if the GPU goes down and everything, and this automatic health check has tendency just as soon as there is a problem, just to kill the node and make it absolutely not accessible. I think like for our user will be like absolutely the wrong idea, the wrong things to do. Say no, okay, you can't access your checkpoint anymore. We will have a lot of users going and ask the administration, how can I retrieve my checkpoint? And they will absolutely hate that because it will create a lot of extra work for the administrator and everything. So, and if you have a GPU that they die quite frequently. Okay, it's fine if the node is still accessible, but not by the user because it will probably put offline by any node health check.
Right.
Okay.
Well,
Sean?
that was a good discussion.
Sean's got a comment?
Right. So I'll start the discussion again. TREs, trusted research environments, really interesting. One of the essential things, I think, for the TREs is the ability to store data encrypted. Now, this may be in anticipation of a talk later on, I don't know, but have you looked at the performance impact of encryption on Lustre, at least on the file system, if not on the network?
I have not looked at the performance impacts, but I know it is certainly possible, and it's quite cleverly developed. It uses client-side encryption, which is incredibly cool, because even if another random client manages to get access to the root of the file system, they cannot access the data unless they have the key. So you share your key between the clients in one trusted research environment. If accidentally another untrusted one gets access to it, they don't have the key, so they cannot get it even if they can see it, which is a wonderful design, and I'm very happy with that. But as for the performance, not sure.
Well, the Andreas.
I was just going to say, I mean, I have a graph in my presentation
There we go.
on this, but no, encryption performance of modern CPUs is built into the hardware, and so it's very fast. It's multiple gigabytes a second per core, and so usually the encryption performance is not even measurable, as long as you're not doing really small files and things like that. And typically it's the storage bandwidth that's the limiting factor, and so the encryption is almost free.
And you get encryption in flight for free, which is another big plus.
That's using symmetric encryption, isn't it? That's the reason
John.
why. Yeah.
I'd just add to that there are obviously more complexities than that. If you are having TRE per project, then you can go with the file system level provided stuff. But if you're having a TRE per institution, say TRE per department, there may be projects within that whose risk is sufficient that you end up having to go for user level encryption above the file system because it's the only way to get the box ticked.
Yeah, and I think actually John's right. I think certainly the way our university is thinking of moving is for a single TRE because they're so hard to administer, and then the projects are secure inside. And actually TRE is a bit of an ambiguous abbreviation in terms of how it's commonly used, I think, for that.
I'd perhaps say administer's not the issue, get signed off is the issue. If you can spin it up in 10 seconds and it then takes 3 months to get a sign off, it's not terribly useful.
Yeah.
Thank you, John. Any other questions or comments on what we've
just a comment on that? I mean, the Lustre FS crypt, can be configured on a per directory basis. So then, it's up to the groups to administer the keys, and the storage admins can't get access.
And then, and the joy you have to think about is have to give the keys to the users, and therefore you have to make sure they're not losing them as well.
Yes.
Which is, it's all procedure, but yeah.
You can set up recovery keys as well.
How are we doing on time? 5 minutes. Any other questions or comments?
Alistair.
Alistair.
So kind of related to the flash topic that we've been talking about, I read recently that the embodied carbon of flash is almost an order of magnitude higher than spinning disks. So we perhaps, unless we really need flash, shouldn't be thinking of going all flash.
That's an interesting observation. I hadn't considered that. From a green computing perspective, flash is perhaps not the direction to go in.
That's right, and even if you factor in electricity and assume a 10-year lifetime, the solid state will survive that. A spinning disk needs one replacement in that time. The spinning disk still wins on a carbon perspective.
Then maybe I can do a panel in reverse. Do you know if tapes are better?
Tapes are even better, yeah.
Oh, how fantastic.
Tapes are not going to reach the end of their lifetime anytime soon because they're nowhere near the areal density of information that a spinning disk is. And there's no reason that they can't match. It's just, I believe people have run prototype tapes at 0.5 petabyte. So what will be LTO-14 has been made and run as a prototype. I think it was 576. You can multiply it up. And that's raw. I think John was thinking about a question.
Just to give you a little bit of information, we in the Met Office, we use tape a lot. So all our data and everything will finish into tape. But in terms of green, one of the things we were asking in the procurement was we have to be able to reduce the carbon and everything. And one of the solutions was used was starting from the source. So the technology, yes, but it's the production of the energy that is green. So the Microsoft proposed to use all green energy for all our supercomputer. So that was one of the point we asked during the procurement was to be able to reduce the carbon of our supercomputer.
John.
I've got a sort of it's a question I asked, it's a different topic. It's a question I asked a couple of years ago. I just wanted to know if anyone's... So we run ZFS entirely on Lustre, entirely on ZFS these days, including on the metadata server. And I've read a bit about Lustre snapshotting, and snapshotting the entire file system in one go. We're talking about backups, and I figured, because obviously ZFS, we've got quite a lot of experience shipping ZFS snapshots about the place. I was just wondering if anyone's actually tried this, or uses it in practice, or... Because it strikes me as that would be an easy way to checkpointing snapshots. I don't actually know how the overall process works, like how you coordinate all the snapshots across the OSSs and MDTs and so on.
This very much sounds like an Andreas question.
Yeah, I mean, the Lustre level snapshots are just coordinating from the back end snapshots, right? So it's just essentially triggering, you know, ZFS snapshots on all of the devices, and then, you know, you can have a file system level barrier, but typically that's actually not strictly necessary. I mean, the barrier imposes essentially, you know, blocks all of your I/O, and practically on almost any, you know, file system, Lustre file system, the atomicity of the snapshot is not at all coordinated with your applications, right? And so having a strict barrier, it's not needed by the file system itself. Lustre can already coordinate between, you know, OSTs and MDTs that are slightly out of sync. And, you know, it's better just to take the snapshot, you know, run a pdish or clush or whatever command, you know, create the snapshot on all your devices. And if they're off by a few, you know, minutes or whatever, not even minutes, tens of seconds, that's totally fine. You'll be able to recover from them or mount them. You know, you can run a command to change the file system name on all the snapshots and then mount the snapshots as a new Lustre file system.
That's what the team is using. So they took a snapshot from a daily snapshot and they have that kind of permanently mounted read-only as yesterday's files. So
Yeah.
if anyone uses it, they can just go and find it.
Yeah, exactly. That's exactly what it's intended to be.
Okay.
The utility of ZFS is quite impressive. It's been a thought of mine, but I must admit my experience with ZFS in production has not been great. I was measuring performance back in the 210 days, and it was not brilliant. I've heard that it might be better these days. Actually, do I have a moment to ask, does anyone actually run ZFS with Lustre on ZFS? Does anyone else? 1, 2, 3. How about Lustre with LDiskFS as a backend? 1, 2, 3, 4, 5, 6, 7. Yes, and also the same people on it as well. Yes. Okay. Well, we do LDiskFS. I probably should have put that in my slides, but yeah.
Okay. I think we've run out of time. Thank you, everybody, for your comments and your